Okay, we're on pages 152 and 153 in your workbook. And so I just want to do some of these because the point of these, unlike the last sheet we did, is not to try and simplify whatever it is, but just to get you to practice converting back and forth between fractional exponent form and radical form. Most of these will not simplify. They just want you to, be fluent in how to rewrite them. So let's just do a couple of these so you understand the directions. So it says write each expression in radical form. So again, your answer should have some symbol like that in it. Again, it might not have anything here because it's a square root, or it might have a 3 here because it's a cube root or something, but they just want us to rewrite it. And again, if it's something simple like this where there's a numerator of 1, all you're going to have is, regardless of whatever the base is, you're just going to have that radical. But in problems like 2 or 3 and 5, where there is a non-1 in the numerator, we're going to have both a radical and a power. All right, so we just have to make sure that we do both there. So let's just take a look at these first 3. All right, so 7 to the 1/2, this one's pretty straightforward. It just means the square root of 7. Again, that 2 indicates square root, so we would write it like this. Again, if you want to go crazy and write it like this, you can, but nobody ever writes that. I would say that this would be the more appropriate thing. People would be like, what are you doing there trying to confuse me? So I would say this is not wrong, but please don't write it like that. Just write it like that. Okay. The next one, again, remember that denominator indicates the root. That's the little number that sits on that, the ledge there. And then this is the power. And so we could actually write this in 2 different ways. So this would be the cube root of 2 to the 5th power. That is how we have been doing it on we're doing it that way on our other sheet. We were taking the cube root first and then raising it to the 5th power. However, it's not wrong if you write it as the cube root of 2 to the 5th, right? Where we would do 2 to the 5th first and then take the cube root. I would probably prefer that you keep it this way just so that we continue to practice making it smaller first before we make it bigger. So again, with the cube root, trying to decrease that number and before we increase it. So my preference would be this, but it is completely correct if you write that. And it especially doesn't matter if you can't simplify it. Like we can't take the cube root of 2. It's an irrational number. So it doesn't matter whether we do the cube root of 2 to the 5th, like this, or if we do cube root of 2 to the 5th, because neither of them can be simplified. All right, so how about you do that one, number 5. See if you can come up with an equivalent expression. I'll pause. You can pause for just a second. Okay, so I would probably write this as the square root of 6 to the 3rd power. Right, I can't simplify the square root of 6. Again, remember, it's just 2 times 3. There are no perfect squares in there, so it's got to be stuck like that. But you could also write it as the square root of 6 cubed. Right, again, I would probably prefer that because you can't take the square root of 6. It is fully simplified, but there are perfect squares in 6 cubed, so whoops, I would probably prefer, I don't know what I said, if I just boxed that in or if I said I would prefer that. I prefer this, no matter what I said. I prefer this one because you can't take the square root of 6. It's fully simplified, but you could take the square root of 6 cubed and get some square root that comes out, or some perfect square that comes out, and some other number that doesn't come out. So that would be my preference. Okay, you feeling all right? Okay, so let's take a look at this next section. Writing each expression in exponential form. So this already has radicals in it and exponents, and so it's asking us to write it as some numerical number, like some whole number with some fractional exponent up here. All right, so no radicals left in it. They don't want that anymore. So let's ignore that cube right out here and just look at this square root of 10. So how would we write that with a fractional exponent? So hopefully you're thinking, oh, I would write that as 10 to the 1/2 power. And you would be right. And then we cannot forget about the fact that we have this cube on the outside. Right? Now, what we would do is we would use our properties of exponents to say, oh, 1/2 times 3, that's 3/2. And so we would write our final answer as 10 to the 3/2. Okay, how about this one? So again, let's ignore that 5. I'm not going to write it again. So I'll just say, let's look at this 4th root of 2, and how would you write that? All right, so I would write it like this, the 4th root of 2. And then again, we can't forget that 5 that's out there. Oh, duh. I'm so used to doing the ones above. That's exactly how they just had it. Okay, sorry, I was distracted because my phone keeps beeping. Okay, let's try that again. We want to write it as a fractional exponent. So I would write this as 2 to the 1/4 power. But again, we have to remember that there's this 5th power out here. Right? So I just... Okay, I'm back. Sorry, I'm not sure what happened there. Okay, so we were just talking about problem number 9. And I said I would write it as 2 to the 1/4 because of the 4th root of 2 to the 5th power. Right? And then we would use our multiplication property for exponents there, and this would become 2 to the 5/4. All right, how would you pause the video, and I want you to do number 11 on your own. Okay, so then this should be just 2 to the 1/3 power. There is no power on the outside of it that would give it an exponent other than 1 in the numerator. So it's just 2 to the 1/3. Okay. So now it's saying to write each expression in radical form. So same thing that we did right up here, except now there's variables included and there are some negative exponents. So let's just do these two and then I think we'll stop here. So this is saying that we want to raise 5x to the negative 5/4 power. Right, so again, this means 5x to the 1/4 power, and then to the negative 5th power. And in fact, we can even break that down even further and say that it's to the 5th power, and then we could say it's the negative 1st power. That way we see what each thing does individually. This takes the 4th root, this raises it to the 5th power, this flips it upside down. All right, so again, if you just want to group the negative with one of them, that's fine, but I'm going to separate them there so we can do each thing individually. So this says take the 4th root of 5x. All right, 4th root of 5x is going to look like this. We're going to put the 5x under here, and we're going to say we're taking the 4th root with that little index right there, the 4. And then it's to the 5th, and then it's to the negative 1. Right, so to the 5th, actually, that's not really going to do anything. That is just going to stay like that. Again, we solved problems like that up here where we had to the 5/3 and we just wrote it just like that. We left it that way. So technically, if we didn't have that minus sign, we could just leave it like that. All right, but now with the minus sign, it means to flip it to the other side of the fraction. So this is going to become 1 over the 4th root of 5x to the 5th power. Right, so again, each of these parts of the exponent do something different. All right, how about this one? 10n to the 3/2. This would be 10n to the 1/2 cubed. All right, that should give you the square root of 10n to the 3rd power. All right, let me just look at what's on the next page and see if we want to go any further. Oh, this one's a little tricky. All right, what would you do here? We have 6v to the 1.5. Again, we've not talked about decimal exponents, but I'm sure that you could think of a way to handle that. What do you think? Maybe somebody's saying, well, how about we write it as a fraction so that we would write it as 6v to the 3/2. Again, 1.5 is 1.5, so the fractional way to write that would be to the 3/2. All right, and that's what I would do. So take just a second and I want you to figure out what that is. I'm not going to pause because I feel like you can do this pretty quickly, so go ahead and do it. I'll wait. Okay, so hopefully you said you take the square root of 6v and then you cube it. And that would be it. Okay, so these problems right here, right in exponential form, are pretty similar to what we did on the other side, again, except now there's variables with it. And then this is a lot like what we did on that worksheet before. Actually, let's do numbers 29 and 30 together. So x to the 6th to the 1/2 power. Right, this is actually not nearly as bad as it looks. Again, let's use our exponent rules. What would happen when we have a raised to the 6th and then raised to the 1/2 power? What would that become? You said x to the 3rd power. Again, we multiply the exponents, so 6 times 1/2 gives us 3, so this is just x to the 3rd. This one's a good one though. Let's take a look at that. So I'm going to ignore the negative sign for just a minute, and let's go through and just pretend that this is 64n to the 12th to the 1/6 power. At the end, we'll deal with the negative, and all that's going to do is just flip everything over. So let's just deal with the 1/6 part. So really, this is saying, and again, because this is multiply in here, we can distribute the exponent. There's an implied 1 there. So this is 64 to the 1/6 times n to the 12th to the 1/6 power. Right? So again, it's the 1 times the 1/6, which gives me the 1/6. It doesn't do anything. And then here you could either just write 12 and then to the 1/6, or you could just multiply those and say, oh, I know 12 times 1/6 is 2, so this really is the same thing as n squared. Right, that would be another option. Okay, 64 to the 1/6 though, we haven't done that one yet. So let's try 2 because we don't know. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Yeah, so it was 6 2's multiplied together, gave us 64. So this is 2. Right, so just with 64 n to the 12th, raising it to the positive 1/6 power gives us 2n squared. But we can't forget that it was actually a negative 1 also out here. Right, a negative 1. And again, what that negative does is it just flips everything. So that 2 is going to flip to become a 1/2. And that n squared is going to flip as 1 over n squared. And so final answer would be 1 over 2n squared. Okay, that's it. See ya.